The distribution curves are similar, but not identical. They show that there are some differences that must be either in the core pin diameters or in the plastic molding conditions in each cavity. If we combine all the measurements to make a distribution curve for all 4 cavities, we have a curve showing the dimensional control capability of the mold. To establish an SPC program for this part, we must take measurements of parts from each cavity and plot them on separate charts to see if there are differences. The part dimensions from each cavity could have a different average or a different spread. If changes between cavities are occurring, we must find and correct the cause before we can establish control limits. When the process is in control and we've determined the process capability, we no longer have to wait until a large number of measurements are taken to find out if the process is changing. We can determine if a change is occurring very quickly using statistical process control. SPC allows us to predict with a high degree of certainty whether a process is changing based on the most recent measurements. The method we use is to plot measurements on control charts. The average of the measurements are plotted on the X-bar chart, and the range between the highest to lowest measurement is plotted on the R chart. The data points are plotted at specified time intervals, in this case, every 30 minutes.